Hello everyone, good morning. Dear authors and invited guests, welcome to the technical session 8F. My name is Siddhi Auti and I'll be your session moderator for today's conference. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligent System, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held via Zoom meeting yesterday and today. I hope you will enjoy this knowledgeable and interactive session throughout the day. Now, in this session, we will be having total 10 presentations, and each presenter will be given a time span of 8 minutes for presentation, and 2 minutes will be given for questions and answers. After 8 minutes, I will be raising a gentle reminder. Also, there is another request to all the participants that you'll stay connected with us till the closing remarks. If you face any query or have any issue, you can write it to me in the chat box. Now, just before we get started, I would like to introduce you all to the today's session chair, Professor Ronak Kumar Patel. Professor Ronak Kumar Patel is an assistant professor in the Computer Engineering Department at CSPIT Charusat. With over 7 years of research experience, his expertise spans machine learning, deep learning, and recommender systems. His areas of interest are Python programming, parallel computing, high performance computing, operating system, documentation using LaTeX. Welcome, sir, to today's session. Now we'll proceed with the participants. So the very first participant we have here today is Rubika Vashal from Tribhuvan University, Nepal. And the paper title is A Comparative Analysis of Transformer-Based Models for Abstractive and Extractive Long Text Summarization. I request Rubika ma'am to please start with your presentation.
Hello, am I audible?
Yes,
Shall I please share the screen?
yes. I'll stop sharing my screen now. You will be able to share.
Hello everyone, I am Rubika Bashal and I'm going to present our paper on a comparative analysis of transformer-based models for abstractive and extractive long text summarization. We are four authors. I am Rubika Bashal along with Bindu Paudel, Nija Mahajan and Saurabh Kumar Gimire. And we are from the Department of Electronics and Computer Engineering, Kulsa Campus, Institute of Engineering, Yuvan University, Nepal. So starting off with the introduction, text summarization is the crucial process of condensing documents while also preserving their key information and meaning. Likewise, long text summarization means the extraction and generation of meaningful insights from lengthy documents. So talking about text summarization, there are two types of text summarization, abstractive text summarization and extractive text summarization. So abstractive text summarization generates entirely new phrases and sentences which are not originally found in the original text. As you can see in the example, the abstractive summary has generated the summary using the words that are not originally present in the original text. And in contrast to abstractive summarization, extractive summarization identifies and extracts key sentences or phrases directly from the original text. As you can see in the example, the extractive summary has used the words from the original text to represent its summarized meaning. Now, moving on to related works. So the first paper here, it highlighted the strength of algorithms like BART and T5, but it did not evaluate the scalability of these models for long form documents. Likewise, the second one was limited on comparison study of models of only scientific text. And for the third one, its limitations were similar to a single domain, which was news articles. And for the fourth paper, while it did offer valuable insights into the state of the art methods, it lacked experimental evaluations or comparison between specific models. So our major objective for this study was to provide a comparison of the state of the art transformer based models for long text summarization. So we analyzed both abstractive and extractive approaches using standardized evaluation metrics like the ROGUE scores. And through this comparative analysis, we aim to identify the strengths and weaknesses of various transformer architectures across different document types and summarization tasks. So there might be a question on why we opted for transformer-based models. Well, transformer models, they have revolutionized the natural language processing task, including summarization, and their self-attention mechanism excels at capturing long-range dependencies between words and concepts, making them particularly valuable for understanding comprehensive documents. And unlike previous traditional approaches, consisting of the recurrent architectures, transformers can also process text in parallel rather than sequentially, which enables more efficient handling of longer sequences. So these are the key components of long text summarization. First, the input representation. It strategizes and breaks the text into manageable units while also maintaining the contextual continuity. The encoder and decoder architecture then encodes the input into contextual representation before decoding into concise summaries. And these encoder and decoder architecture consist of attention mechanism, which identify the most relevant part of the input with different strategies for computational efficiency. And positional encoding techniques, they retain the sequential order or order to understand relationship between the distinct tokens. Finally, the hierarchical processing, it divides the text into smaller units like sentences or like paragraphs before it combines their representation to produce cohesive summaries. And for evaluation, we have opted to the ROGUE matrices, and all these matrices are evaluated on CNN, Daily Mail dataset, RZIV, and PubMed datasets. Now talking about the transformer-based techniques that we have analyzed, starting off with abstractive models. So long T5 extends the T5 architecture using sparse attention to reduce computational complexity for long documents. Big Bird Pegasus, it implements block sparse attention, focusing only on global tokens and local blocks to handle longer sequences efficiently. The HAT part extends BART with hierarchical attention mechanism that process document into chunks before aggregating it with global context. And finally, we have DIAL. DIAL generates abstractive summaries by modeling latent variables that control the generation process. Now moving on to extractive summaries. So in extractive summaries, the burst sum processes sequences using burst standard self-attention mechanism, but it might face some challenges with longer documents due to quadratic complexity. And moving on to LED labs, it adapts the long former architecture with sparse attention for better handling of long sequences. And headformer uses heterogeneous attention mechanism designed for multimodal or multi-source summarization. HiStruct Plus, it implements hierarchical structure summarization, and this type of structure summarization architecture is particularly effective for scientific paper and legal documents. Likewise, long trans EXTR adapts transformer models specifically for extractive summarization with sparse attention mechanism to improve efficiency. So these are the results, and our evaluation reveals several key results like the long T5 achieved the highest performance on PubMed dataset, and it had impressive ROGUE score across all matrices. And among extractive models, HiStruct Plus performed the best on PubMed data. And generally, we found out that abstractive models outperformed extractive approaches across most evaluated dataset, and performance varied significantly between dataset, indicating that the models have domain-specific strength. So these are some of the visualizations of the result. On the y-axis, we have the ROGUE scores, while on the x-axis, we have the models. And these different colors denote different data sets. So there were several key findings from our study. Abstractive models, particularly long T5, demonstrated superior performance for long text summarization across most metrics, as I mentioned earlier. And we found out that the specialized architectures designed for scientific literature, like that of Hardbart and HiStruct Plus, it showed particularly strong performance on domain-specific content, and the computational complexity varied significantly between models, with those having sparse attention mechanism, enabling more efficient processing for long documents. And the dataset characteristics also strongly influence the model performance, suggesting the importance of domain-specific fine-tuning. This, looking ahead, we also have several promising directions that emerge for future research. Like the first one could be fine-tuning with domain-specific dataset that could improve performance in specialized fields like medicine or law, and developing hybrid extractive-abstractive approaches that might achieve better coherence and factual accuracy. And we could also explore alternative evaluation metrics beyond the ROGUE scores, and including BERT scores and human assessment for more comprehensive evaluation. And finally, post-processing techniques such as fact-checking modules could also be used to verify summaries against source text to ensure accuracy. So in conclusion, our study concluded that the transformer-based models show promising results for long text summarization. And while choosing models, the facts that should be considered are the type of the document, the domain, or on which data set or for which data we are trying to apply the model, and the computational constraints. So this study provides a guidance for selecting appropriate summarization approaches, and the field continues to evolve with new architectures and techniques, which obviously means contribution to the development of more robust systems. So these are the references. Thank you.
Thank you, ma'am, for your presentation. Are there any questions? Okay, let's proceed to the next participant. So the next participant is Senthil Kumar from Dayanand Sagar University, India. And the paper title is A Comprehensive Deep Learning Framework for Physical Vehicle Fitness Testing and Document Validation. Sir, if you're there in the meeting, please start with your presentation.
Yeah, good morning, all. Am I audible, madam?
Yes, sir, you are audible.
Yeah, thank you. Yeah, so I'm Dr. Senthil Kumar from Dayanand Sagar University. Our title is a comprehensive deep learning framework for physical vehicle fitness testing and document validation. Here is the list of the content of my presentation. So here, the introduction. The road accidents claims the lives around 1.5 million people yearly and injure an additional 50 millions. Vehicular condition is as an important factor for road accident. Old vehicle harms the environment and poses safety risks. Every vehicle need undergo mandatory fitness test in which the examiner will validate the document like pollution under control test, registration book, insurance, claim history, etc. The government authorities will check all the physical parts, looks for any damage in the body, in the working condition of instruments, light, etc. This testing is currently mandatory for the vehicle whose age is more than 15 years for the private vehicles. And after every 5 years, once it will be repeated. So the whole process of getting this vehicle fitness tested is manual so far, is quite agile some for both owner and the inspectors. The complete process contains a lot of paperwork and there is a very minimal use of technology as well. There are new regulations for vehicle exhaust exhibition to improve air quality, such as BS6 adherence to these restrictions. It emphasizes how urgently sustainable solutions are needed. So the main objective of this research is to propose a framework and automate vehicle fitness testing and documentation validation process with our CNN, YOLO V10 computer vision technologies. Here is the proposed architecture in which the vehicle will be captured through the camera located at the traffic signals. From that, the image of vehicle will be identified. Once the vehicle is identified through R and CNN, then the number plate in it will be detected. The number plate location in the image will be detected with the YOLO 10. From then the number of the vehicle will be converted into text by using OCR. And finally, the OCR information will be fetched from the database to check the details of the particular vehicle. That is, and if there is the validity is expired, the appropriate action will be taken against the vehicle owner. So in order to do that, the proposed framework consists of pre-processing work and feature engineering, like image conversion into black and white, edge detection, object detection, kind of thing. Then the number plate detection, OCR, dent detection, light detection will be done on the image, processed image. Then finally, the information will be fetched from the database and the final results about the particular vehicle will be shown. This is the idea of the paper. So here, as we discussed in the architecture, the image from the traffic camera, through the traffic camera, image will be captured and vehicle will be identified, and the fitness vehicle number with the OCR is detected. The pollution control certification is validated, dent will be detected. So for training the model, RCNN COCO dataset is used. And finally, we used 150 approach. Each batch contains 8 images. And here is some of the level, the training level and training accuracy is calculated. The con bias indicates the basic level and stability in training and learning dynamics. The con1 kernel 0 indicates the starting weight, how the neurons are initialized, that are shown here. The training accuracy level and the weight, initial weights, how big is the system is indicated here. So this particular system can be used not only for detecting the vehicle's fitness level in future, it can be used for the automating with the multiple sensors. Instead of a visual inspection, it can be used for various other tests like testing of acceleration, brake, power, the tire health, everything it is possible to measure. Here are some of the references. Thank you.
Thank you, sir, for your presentation.
Thank
Are
you.
there any questions, or should I proceed further? We'll go on to the next participant. So the next presenter is Rupali Kote from MIT World Peace University, India, and the paper title is A Deep Learning Based Assistant for the Visually Impaired. I request Rupali ma'am to start with your presentation. Hello, am I audible?
Yeah.
Yes, Siddhi, you are.
Rupali ma'am, I request you to please start with your presentation, if you can hear me. We'll go on to the next presenter.
Yes, sure. I'm Hector Morano.
Yes,
fourth.
sir, would you be able to start with your presentation now?
Yes, sure.
Okay, then.
Okay, hello everyone. Hi, Hector Morano. I work for Tecnológico de Monterrey. The title of this presentation is Artificial Intelligence, Exploring Large Language Model for Calculating Forces in Trusses. This is the agenda I'm going to follow. First, I will enlist the objectives of this work. Then I will describe the methodology that we use. And finally, I will share the conclusions and future work. So here we have the objectives of this work. The first one was to identify the diagrams of a trust from an image. The second one was to extract the length of each member of the trust. And the last one was to calculate the axial forces of the members of the trust. So exploring LLMs in structural analysis allow us to identify their scope for use in industrial and educational applications. For example, users could benefit from the automatic calculation of trusses by interpreting a drawing, or university students could be helped by artificial intelligence assistants in learning the procedure necessary for structural analysis. This work was developed during the System and Technologies 4.0 course with the participation of just 7 mechanical engineering, mechatronics, robotics, and computer system students in the 6th semester. The computing resources used were laptops with i7 processor at 2.5 gigahertz and 32 gigabytes of RAM. This is the methodology that we use. We could say that consisted of a series of activities covering the research objectives. Figure 1 shows the sequence of activities carried out for this research. We implemented 6 activities, which I will describe in the following slides. The first activity involved investigating the version of ChatGPT in use. The answer was ChatGPT 4 with information from June 2024. The second activity was to investigate whether the LLM could recognize a trust diagram from an image and what information it could identify. The image provided to the LLM is shown in Figure 3. It was decided to use a basic 2D truss to evaluate the LLM capacity. The prompt used and the response are shown in Figure 4. To understand the possible confusion that the LLM could have about the image of the truss diagram, it was asked what ambiguities it detected. For this purpose, the third prompt shown in Figure 5 was used. At the bottom, we see the conditions must be specified to clarify things better. The LLM was then asked to calculate the remaining lengths to show in the image. To do this, the prompt in Figure 7 was used. In this, only the summary of the result of the length calculations are shown. Although the LLM show all the trigonometric calculations for obtaining each length, however, the length of member BE was wrong because it was confused with its magnitude, considering that BE was equal to the horizontal distance of 6 meters between the cosine of 25 degrees, which is 6.62 meters. However, for the other lengths, they were correct. Finally, the LLM was asked to calculate the axial forces in each truss member. The prompt in Figure 8 was used. The response only include the result of each axial force since the LLM provide all the calculations to obtain them. However, it included the error in calculating the length of member BE, but the LLM was also asked to mention whether the members were subject to compression or tension. For example, equations from 1 to 7 were used to compare the calculation results of the axial forces in each truss member. When the LLM was asked to interpret the image, it identified that it was a truss with 5 nodes at A, B, C, D, and E. It also located its member employing green, red, blue, beige, and yellow colors. Two vertical forces, P1 and P2, act at D and C, separated by 3 meters. It also detected two supports, A and E, and the green and beige members are inclined at 25 degrees relative to the horizontal member. The ambiguities identified by LLM are shown in Table 1, where the type of supports at nodes A and E was requested to be confirmed just to determine their reactions. The loads P1 and P2 are required to analyze the thrust. The types of joints and materials are also needed to establish each member's axial forces and stresses. It is also necessary to name each structure member to refer precisely to each of them. Finally, it is essential to specify the inclination angles of each member just to calculate its interaction with the other members of the trust. But when LLM was asked to calculate the length of all the trust members, it did so without any problem. Only the length member BE was incorrect. Table 2 shows the magnitude of each of them. The image interpretation obtained the length of the ED and DC members. In the calculation of the axial forces of each member, the axial forces of elements BE, CD, and BC were correctly obtained. In the case of member AB, the LLM obtained that it was subject to compression. However, the correct answer is that it is in tension. Table 3 shows the result of the calculation of the axial forces of each member by the LLM. It can be observed that for all the members that have contact with member BE, their axial forces were incorrectly calculated since the error in calculating their lengths influenced the results. So here we have the conclusions and future work. First, the LLM correctly interpreted the image as a thrust, identifying the nodes, their different members, the supports, and also the location of the loads. An image resolution of 96 pixels per inch is enough to recognize a truss. A lower resolution could deform the truss elements. However, the LLM could not correctly calculate all its member length and axial forces. Asking about ambiguities helps the users include relevant information in the prompts to perform the queries, ensuring that the LLM will understand the problem described. Also, images containing the information the LLM requested when establishing the ambiguities may result in better calculation. It is recommended that more complex trusses be used to explore the result that LLM will offer. We also can use other LLMs, such as Copilot or Gemini, can also be explored. This could compare the result of the different LLMs. So that's it. Thank you very much. If there are some questions, I'll be glad to answer them.
Thank you, sir, for your presentation. Uh, Rupali ma'am, you can present now. You can start with your presentation.
Yeah, thank you, Siddhi. I'll just share my screen.
Yes.
Hope my screen is visible.
Yes.
Okay. My paper ID is 755. Myself, Dr. Rupali Kutte. I am going to present a topic on a deep learning based assistant for the visually impaired. Authors for this paper are Sankal Kadam, Vinaya Gokul, myself, and Dr. Bhakti Peranspe. So, on behalf of this author from Dr. Vishwanath Karad, MIT World Peace University, Pune, I am presenting this paper. So, the introduction is basically, from India, nearly 1.5 million people are visually impaired, and 170 million globally are visually impaired. And what problem they are facing is to detect the staircase. Nowadays, even if the staircases are being detected, but it is difficult for the visually impaired people to identify whether the staircase is going upstairs or whether it is a downstairs. So it is very hazardous due to varied designs, angle, and lighting. Therefore, our aim is to detect the staircase and classify them as upstairs or downstairs using the deep learning. So significance after implementing this is it prevents the accidents and enhancing mobility for visually impaired individuals. So what literature review we have done toward this is there are different methods to identify the staircase. So these methods are based on the sensor level. Like there is a nowadays this is also available in the market like a smart cap, iris, made glass. So this methods based on the sensors and they can identify whether there is a staircase or not. But they are not able to detect whether the staircase is going upstairs or downstairs. Then we have done the literature source survey towards what methods to be used if we wish to identify it as a upstairs or downstairs. So there are methods like based on object detections like fast RCNN, faster RCNN, SSD, RaceNet, MobileNet, Mobile V2 for object detection, and there is a limited work done in the staircase classification. So this is what the gap we have identified, that there is a limited focus on up or down staircase classification. Therefore, what we have proposed is we have proposed a VGG19. We have proposed basically two methods to identify the staircase. One is based on image classification and one is based on object detection. So in image classification, we have prepared our customized dataset by clicking the photographs available in our own building in the college premises. Then we have labeled the images, we have annotated the images for image classification. We have labeled the images as upstairs and downstairs. Then different pre-trained classification models we have used like VGG16, VGG19, Inception, Exceptional, Exception Net, Mobile V2 Net. Then what we have observed is VGG19 performs best. So therefore, here I have put VGG 19 as a pre-trained on ImageNet dataset and fine-tuned basically for the binary classification as upstairs and downstairs. And at the last, after training the network, then the test data is provided to classify the images into upstairs and downstairs. Another approach we have proposed that is based on object detection. So in object detection, as you can see in the custom data set, as I said, prepared, we have annotated the images manually whether stair is upstairs or downstairs. Then we have used the different pre-trained object detection networks like CNN, faster RCNN, fastest RCNN. Then what we have observed is faster RCNN performs better as compared to other models. And here in the annotation, in the final result, it shows uh, if we have a multiple objects, for example, camera is capturing multiple objects. Out of this, This model will show a particular bounding box with a staircase, and it also shows that whether it is a upstairs or downstairs model. Then, as I mentioned, while proposing this method, we have prepared our own data set, and we have pre-processed the data set. These are the few images from the data set. So nearly 500 plus label images we have collected. We have classified them into upstairs and downstairs. For annotating the image, we have used a tool label IMG. So using label IMG, we have annotated the images into upstairs and downstairs. Then we have applied few augmentation steps to increase the data set, like we have flipped the image, we have done the color transformation. Then this data set is classified into training, and we have splitted the data into training and testing. We have also made this data set online. So the link is provided. So using the links, you can see the data set is also available on the main link.
Um,
After,
Ma'am,
yes,
sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
yes, I'm about to that only. So then this performance metrics we have used like accuracy, precision, recall, and F1 score. This is a comparison performance for the staircase classification, and you can see such different models we have used. And out of this, it shows the VGG19 gives the best performance, that is 83% accuracy. And similarly for staircase detection, as I said, we have used RCNN, fast RCNN, and faster RCNN. And it shows for a faster RCNN, it gives the best performance at 78% accuracy. So these are the few images detected by VGG19. Here you can see a label like upstairs and downstairs detected by VGG19. And these are the results obtained from faster RCNN. So here in the image you can see bounding box with the upstairs and downstairs images, along with precision recall, mean average precision, uh, shows that it performs better with increasing uh, with the number of epochs. So the conclusion is there are basically two conclusions. VCG19 in the image classification achieves a good accuracy, and in the object detection model, faster RCNN achieves the best accuracy. So practical impact of this method is, this is what is a um, socially social problem we have addressed. And future direction for this is we can expand the data set for the diversity, and we can also integrate the higher models for the better accuracy. These are the few references, and thank you. So now I'm open for the question and answer.
Thank you, ma'am, for your
Good morning,
presentation.
ma'am.
Yeah.
So, means how you are going to implement this uh, thing for real application?
This is basically camera based application where in real time, if we have a stick, and with the stick, if the camera is attached with the module, so you can capture the image with the help of the camera and the model. So if we want to have a model, standalone model, so we have to integrate the IoT into it. So with the IoT, we'll have a small hardware setup. Along with the hardware, we have to integrate a camera. So using the camera, it will capture the image. The image will be fed to a standalone system like IoT based, and then we have to attach a speaker. So whenever the image will be captured, it will be provided to like Raspberry Pi or ESP32, and through the mic, through the speaker, it will say now this is upstairs or downstairs.
Okay.
Thank you.
Thank you, ma'am. Thank you, sir. Now I'll proceed to the next presentation. So the next paper title is Automated Detection of Unhealthy Retinal Optical Coherence Tomography Images Using Geometrical Features for Machine Learning Modeling. And this paper will be presented by Mithavi Ratanapurpuram from Thammasat University, Thailand. I request ma'am to please start with your presentation.
Can you see my screen?
Yes.
All right. Okay, so my name is Methavi Ratanapumpam, and I will be the representative of this paper, Automated Detection of the Unhealthy Retinal Optical Coherence Tomography Images using the geometrical features for the machine learning modeling. So the agenda of this presentation will be outlined as follows. First, let me introduce you about the optical coherence tomography, or the OCT. OCT is a medical imaging technique that is pretty similar to the ultrasound, except that it uses the light instead of sound. And OCT can be used on many organs, but today our focus is on the retinal OCT, or the OCT scan of an eye. The retinal OCT shows the cross-section of tissues at the back of your eyes, and in this area there are many different tissues layers, as shown on the example image. The doctors use these OCT scans to diagnose the retinal disease and keep track of the patient's condition. And because the symptoms of the retinal disease are often recognizable by both the anatomical structure and the morphological changes of the retinal layers. Example on the left is the OCT scan of the retina in the normal condition, while the set of images on the right show the OCT scan of some common diseases. You can see that the layers are not smooth and distorted. And the OCT image of the normal retina display a distinct and well-layered structures with the clear differentiation between the retinal layers, while the abnormal retina can show the disruptions or some cystic spaces and the abnormal fluid accumulation. And nowadays, there are many implementations of machine learning and deep learning in classifying between normal and abnormal retinal condition. And with the characteristic of the retinal layers, the retinal thickness is one of the most effective and most commonly used features to classify abnormalities in many studies. But it can be affected by the image quality and the condition of the retina, especially in the disease image. On the right, you can see that the layers can be so distorted that it can be hardly seen or identify what layer it is. And one of the recent study from Namsonti et al. Utilized the intensity line profiles to identify abnormal LCT images. Intensity line profile is taking or drawing the vertical line across the image and plotting the intensity values obtaining from that line and plotting them all together. You can see on the right is the plot of the intensity line profile of the image. The normal OCT scan produced quite uniform ILP pattern, while the abnormal one has a messy ILP pattern. However, the method was sensitive to the symmetry of the image, even though it has overcome the challenge of using the retinal thickness. The normal scan that is slightly tilted, for the example on the left, can produce the messy ILP pattern, which is pretty similar to the abnormal condition. And with this challenge, we have come up with our research problem. While the inner retinal layers could potentially be distorted in some disease OCT image and make it harder to utilize the retinal thickness features in some cases, we choose to focus on the easily detected layers. And with the nature of the retina to be symmetrical in normal cases and distort in the abnormal cases, we hypothesize that the symmetry of the retina is the key feature for classification. And with this challenge that I addressed, we proposed the method to classify the retinal OCT image using the simple features related to the symmetries and smoothness of the inner limiting membrane, or the ILM layer, which is the blue line. It is the topmost retinal layer and can easily be seen even though in the disease image. And also, we utilize the use of retinal pigment epithelium layer, or the bottommost brightest layer, to detect the unhealthy image, because this layer can also be easily seen even in the severely damaged retina. And our methodology for this study is outlined as follows. First, we will start with the pre-processing step. We remove the unnecessary areas of the image, and then we do the perspective transform to define the rectangular region of interest. Then finally, we do the noise reduction to remove noise and preserve the edges. After we do the pre-processing, we process with the layer segmentation. We will first extract the ILM, or the topmost layer. We use the Otsu's thresholding to binarize the image and obtain the outline of the retina. And then we use the layer extraction algorithm to obtain the layer as shown in the blue line on the rightmost image. Next, we segment the RPE layer. As the RPE is the brightest layer of the retina, we perform the contrast enhancement with the contrast limited adaptive histogram equalization, or CLAE, and we do the gamma correction to see the layer better. Then we binarize the image with the Otsu's thresholding and obtain the RPE layer with the layer extraction algorithm. We must note that some of the image is slightly tilted, so after we obtain both layers, we rotated the image to be parallel to the ground, so we can accurately extract the symmetry features. Next step is feature extraction. We extract a total of 4 features. Let's start with the feature 1, or fovea concavity. Fovea is the area at the center of the retina where it is slightly curved downwards. We will find the nearest local extrema to the center of the image, and we will use it as the fovea center, as represented as the green dot. And then we will use 2 reference points, place it on either side of the fovea center to determine the concavity. If the fovea center is located lower than at least one of the reference point, it will be categorized as the convex fovea position. But if the fovea center is located lower than both of the reference points, it will be categorized as the concave. On the right is the example image of the OCT with normal condition, where it has the concave fovea position. And at the bottom is the example of abnormal images with the convex fovea position. Next, feature 2 and 3 is the bilateral symmetry of the ILM and RPE layers. Hello?
Ma'am, can we please get to the conclusion? We are past the presentation time.
We're past the presentation time.
Yes.
So the conclusion is that this study presents the machine learning approach for detecting the unhealthy OCT image by using the geometric features of the retinal layers. And this proposed method outperformed the techniques called vertical line profile method and the traditional image processing methods. And this finding highlight the potential that our approach can enhance the automated eye disease detection and contribute to the advancement in the retinal diagnostics. For our future work, we can still progress further by addressing some challenges in our work, which is detecting the early stage disease and dealing with symmetrical pathologies. And we plan to add more meaningful features to help the model classify abnormalities more effectively. Thank you. Any questions? Am I audible?
Yes, ma'am. Thank you, ma'am, for your presentation. If there are no questions, then we can proceed to the next presenter. So the next presenter is Suhana Singh from Banasthali Vidyapit, India, and the paper title is Deep Learning Based Machine Translation Evaluation Matrix. I request Suhana Singh to please start with your presentation. I think we should go on to the next presenter. The next presenter is Saharsha Tiwari from Howard University, United States of America. And the paper title is Enhancing Geospatial Reasoning in Large Language Models, an Optimized Retrieved Approach Using R-tree-based Point-in-Polygon Nearest Neighbor Search. Saharsha, sir, if you're there with us, would you be able to start with your presentation?
Yeah, absolutely. Is my screen visible?
Yes.
Right. So, hi everyone. So today I'll be discussing our work on advancing geospatial reasoning with large language models by optimizing how they retrieve and reason over spatial data. So the author is me. I'm Saharsa Tiwari, and we have Dr. Saurabh Aryal, who is a senior research scientist at uh, Howard University, and we have Dr. Legan Bird, who is a professor of computer science. So geospatial queries are foundational in domains ranging from urban planning to disaster response and real estate analytics. And these queries operate on spatial data like points, polygons, and regions. And typically, they involve operations like proximity analysis and topological reasoning. So, for example, k-nearest neighbor queries helps us to find the closest facilities, while point and polygon queries determine containment, like checking whether a GPS coordinate falls within a school district boundary. And these tasks, while might sound simple, but they become computationally expensive when scaled to millions of records, especially when they are combined. So now let's talk about the core challenges, which is combining the point in polygon and nearest neighbor search. So the problem intensifies when we combine these two things, and this combination increases the computational complexity due to the spatial constraints. And not only we do identify that all the polygons that contain a point, but we must also rank and filter based on proximity or similarity, uh, often in high dimensional feature space. And on top of that, overlapping polygons or highly dense spatial layouts can really choke the performance and increase the memory uses. So these are the challenges to scaling large language models for spatially grounded tasks. And talking about the challenges for large language models, so general purpose large language models like GPT-4o or Llama are not spatially grounded, and they often lack embedded knowledge of topology or geospatial uh, data. And they also struggle with tasks like recognizing a boundary, intersections, or answering range questions based on latitude, longitude inputs. And also, they uh, exhibit some regional biases, like favoring well represented areas while failing in underrepresented geographies. And even if the structured geospatial data, there's no straightforward way to inject it into large language models due to incompatibility encoding and lack of spatially aware tokenization. So some of the key foundations of geospatial querying with large language models are spatial indexing with R-trees, which are basically hierarchical bounding boxes for fast containment checks and range searches. And these are optimized for sparse, irregular, or high-dimensional geospatial data. And we also employ a two-stage query processing pipeline. So first, we do a point in polygon filtering, which narrow down the candidate set using geometry. And then we do a semantic or feature space nearest neighbor search, which ranks the remaining entries. And this architecture dramatically reduces the the computational load while improving accuracy. And importantly, it complements the retrieval augmented generation RAG by adding a spatial filtered layer that semantic retrievers alone can't handle. So talking about the methodology that we set up, so our experiment simulates a dense urban setting using a synthetic geospatial dataset. We define a large polygon approximating the DMV area and randomly generating over millions of rectangular polygons within it. And they serve as the simulated district or regions. And we also generate 500K sample points for testing the inclusion and distance. So this scale helps us to assess both computational performance as well as the spatial accuracy under high load conditions. So as you can see here, we define three approaches. First one is we do nearest neighbor search and then and then filter the polygons with PIP check until we get the 10 top most similar polygons. The second approach that we define here is point in polygon along with a basic cosine similarity, which is complete, but it's correct as well. But the first approach is complete, but it's not correct because we are getting the similar polygons, but it's not exactly the points are not exactly in the polygon because we are doing nearest neighbor search before the point in polygon check. And the third approach is our approach where we do arbitrary indexing and then we filter it using point in polygon and then we only do the nearest neighbor search. And so talking about the results, so as you can see here, we tried with 1,000 points, 10,000 points, and 500,000 points. So our approach is approach 3, with which always beats the baseline by a really large magnitude, as you can see in the table right here. So the figure in the left you can see is a violin plot, which basically compares the time distribution for approaches 1 and 3, showing the approach 3's median, which is nearly half of that of approach 1. And these results confirm that approach 3 significantly improves speed while maintaining search completeness and correctness. And on the right, we have figure 2, which breaks down our approach into subtasks, and they are labeled as fitting time, predict KNN, and query plus lookup time. So fitting KNN seems to be taking the slowest time, followed by predict KNN and query plus lookup time. So this insight highlights a potential area for improvement by optimizing data retrieval because query plus lookup is taking the longest time here. We also perform a case study where we conducted a case study to simulate a real world use case. Let's imagine a parent in Los Angeles looking for a best school for their child. The location fell into spatial edge case with overlapping school district, and traditional large language models struggle to resolve this issue due to ambiguous administrative boundaries. And our retriever, using precise point in polygon containment, successfully identified both overlapping districts and ranked the school options more reliably. So here's the results that we performed with no RAG using ChatGPT 4o, and then it gets incorrect answer. We use ChatGPT 01, which gives the correct answer. But the last one is our proposed retrieval, which is correct.
Hello,
And
hello. So
mhm.
sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
Yeah, sure. So talking about the conclusion, we focused on two fundamental geometry problems. The first one is pointing polygon and nearest neighbor search, and embedded them into retrieval pipeline that supports geospatial reasoning within large language models. And this not only boosts RAG performance, but also unlocks new use cases where spatial rules are non-negotiable, and we need accurate results. And from school search to zoning and disaster response, this uh, foundation enables more accurate, equitable, and real-time spatial decision making in AI systems. Thank you. And if you have any questions, feel free to shoot out to me.
Thank you, sir, for your presentation. Now I would like to request Rupali ma'am to please start with your presentation. The paper titled Deep Learning Based Machine Translation Evaluation Matrix, presented by Suhana Singh. Ma'am, can you share your screen now?
Hello. Siddhi,
Hello.
can you see my screen?
Yes, ma'am.
Okay. Is it still visible?
Yes.
Okay. So, good morning, everyone. I am Suhana Singh from Banasthali Vidyapeeth. Today, I'm excited to present our work on metal MT evaluation using applied learning.
Ma'am, we can see your screen, but not the PPT.
Okay.
We can see the Zoom meeting page. You have to select the another screen of your PPT presentation. Yes, now we can see the PPT.
Okay.
You
Sorry,
can
sorry.
resume.
Okay. Okay, good morning, everyone. I'm Sohana Singh from Banasthali Vidyapeeth. Today, I'm excited to present our work on metal MT evaluation using applied learning. Now, moving forward, machine translation is critical for global communication. However, accurately evaluating MT systems remain a challenge. While human evaluation is a gold standard, it's time-consuming and expensive. Existing automatic metrics like BLUE and Meteor have limitations, especially with nuisance language. Our paper introduced METAL, a reference-based MT evaluation metric. METAL is trained using deep neural network to better align with human evaluation, making it effective for real-world MT tasks. Now, human evaluation is a very slow process. Humans tend to get tired by performing the same task again and again. Human judges often evaluate automatic translation on several different qualities measures like fluency, educacy, and compositionality. As a result, this process sometimes takes days to complete, might delay the development of MTU system. Human assessments are very subjective. On one hand, we may use multiple evaluators to test the same set of outputs, which always come up with different results. For example, on a 1 4 point scale of fluency, one evaluator may give too little comprehensive to a translation, whereas another evaluator may give three partiality comprehensible to the same translation. On the other hand, evaluators depend on evaluation guidelines involving several criteria which may vary from time to time or project to project and thus may not be used twice. Now, why we should focus on automatic evaluation? Provides Because it provides fast results on demand. Once developed, does not have a running cost associated. Provides a numerical score. Now, automatic evaluation it is this is a reference space. This method evaluate the output for comparing it to one or more human written reference outputs. It will help the model to understand the complex data that usually traditional methods skips or they generally miss. Now, moving forward to literature review. Anti-evaluation has evolved significantly. Blue was a revolutionary metric offering a recall and word order. Meteor improved upon Blue by incorporating recall and synonym matching. More recently, metrics like Comet used contextual embeddings but can be computationally intensive. Metal addresses gaps in existing research by providing a more accurate and efficient metric tailored for Hindi. The automatic evaluation metrics, which perform fairly well for English, do not work well as well with the Indian languages. Almost all the automatic metrics across linguistic levels fail to demonstrate their meaningfulness for Indian languages as they do for English. In literature, for this problem has been highlighted in Anant Krishnan showed that the problem that Blue metric faces in evaluation of Hindi translation. Joshi compared some English Hindi MT system using human evaluation Blue and Meteor metrics and found that these metrics do not correlate with the human evaluation. Thus, use of these metrics is infeasible for evaluating MT systems for the Indian languages. Now, moving forward for the methodology part. Our methodology involves training a deep neural network on a data set of 1.3 million sentence pairs. These pairs include source sentences, machine translation, and human reference. The data set was built from publicly accessible MT corpora, ensuring linguistic diversity. Metal uses seven key features for training: Blue, NIST, Meteor, TR, Looper, and CHRF. The model architect includes a deep learning neural network with three hidden layers. And several optimizations such as ADAM, RMS prop, and SGD. We also employed techniques like dropouts and batch normalizations and early stopping to enhance performance and prevent overfitting. So now how do we actually set up? We trained our model using prepared data set, extracting features from candidate translation compared to human references. The target variable was human evaluation scores averaged across annotators. For testing, we compiled a corpus of 500 sentences from news websites translated by Google and Binge Translator. This allowed us to evaluate a metal against other metrics. Now, Metal use a deep learning deep neural network trained on feature extracted from seven popular MT evaluation metrics, as I have already discussed, along with a human evaluation score as target variable. This approach also allows Metal to capture complex patterns in translation quality that traditional metrics miss. Also, we have tested with multiple optimizers to identify the best performing variant of metal. Uh, now, moving forward for results, we compared metal with established metrics like CHRF++ and Comet, as shown in the table. Metal performance for English Hindi translation using Adam optimization. Metal Adam outperformed CHRF++ and was comparable to Comet. We tested across different MT engines like Google, Binge, and Anwad, demonstrating Metal's robustness. And also, we test Metal Atom demonstrated performance comparable to Comet and better than CHRF++ across various MT systems. For example, in our experiment with English Hindi translation, Metal Atom consistently ranked second after Comet in terms of correlation with the human judgment. Since any human evaluation is a golden metric, so any new metric should have a good correlation with the human
Ma'am,
judgment.
ma'am, could you please conclude the presentation?
Sure.
Yes.
So our key finding was threefold. First, metal aligns closely with the human evaluation. Second, the Adam optimizer yielded the best results among these tested. Third, metal demonstrated robustness across multiple MT system and dataset. These results highlight metal's potential as a reliable MT evaluation metric. Okay. Now, to conclude, uh, Metal is a reliable reference-based metric for Hindi MT evaluation. It addresses limitation of traditional matrices by leveraging deep learning techniques. For future work, we plan to expand Metal to other languages by incorporating language-specific features. So this is, and thank you.
Thank you, ma'am, for your presentation. Now we'll go on to the next presenter. So the next presenter is Usha Wala from Anil Konda Institute of Technology and Sciences. And the paper title is Image GPT, Recognition, Classification and Identification of Dance Images to Create an Insight into South Indian Dance Forms Using Deep Learning Techniques. Ma'am, if you're there in the meeting or any of the co-authors, you may start with your presentation. Think she's not there. We'll go on to the next participant. The next paper title is Remote Diagnosis and Monitoring of Lung Diseases Using DL Models. And this paper will be presented by Hashim Maniar from PES University, India. Sir, if you're there in the meeting, please start with your presentation.
Hello, am I audible?
Yes.
Yeah. Is my screen visible, ma'am?
Yes, sir.
So, good morning, everyone. My name is Hashim, and today I'm here with my co-authors Kusum Ishita Lalit and Sarita to present our research paper named Remote Diagnosis and Monitoring of Lung Diseases. So, let me begin with highlighting why this problem actually matters. So, currently, lung diseases are the fourth leading cause of death worldwide. One of the most crucial challenges that we are dealing with in today's world is that the lack of accurate and early diagnosis of lung diseases. The sooner we can detect them through the patients, the better chances we would have to fight them and have a effective treatment for them and hope a better recovery for the patients. Traditionally, doctors relied on listening to lung sounds with a stethoscope and auscultation to identify potential abnormalities. But this method is highly subjective and dependent upon the expertise of the medical practitioners who are currently diagnosing the patient. In recent years, we have seen that there is a rise in electronic stethoscopes that can actually record the lung sounds digitally within their system. These recordings can be used in conjunction with the machine learning to support our diagnosis. And this forms the foundation of our work which we have done. So as we are dealing with the audio data, we have used the standard pre-processing sampling such as resampling, filtering and normalizing the dataset to match our needs for the model. Now, while using AI for medical diagnosis is very promising, there is a major hurdle that which comes along with it as well. There is an imbalance within the data set. In lung sounds, as we can say that they tend to be a normal samples much more than the abnormal samples, where they are underrepresented. This makes the imbalances makes the model very hard to learn effectively, and it especially affects their ability to recognize rare but critical conditions which might be helpful for the diagnosis of the patient. To address this, we have used a novel augmentation technique called as sequential concatenation augmentation or SCA. So the idea behind this technology is instead of using traditional augmentation techniques for audio data such as noise addition or pitch shifting, what we have done is we have combined multiple abnormal lung sounds into sequence with each other to form new sounds. So what it does is by doing this, we increase the total number of abnormal classes which are present in the dataset. So that we can introduce a greater variability throughout the dataset, which helps the model generalize better as it now has both imbalance, normal and the rare or abnormal data in sequence to each other and in equal numbers. Once this augmented dataset is ready, the dataset is fed into a deep learning model. So the deep learning model combines the feature extraction power of convolutional neural networks with the precision of attention seeking mechanisms. CNNs or the convolutional neural networks help the model understand the lung sounds properly, while the attention mechanism, what they do is they help the model focus on the most important parts of the lung sounds or the signals which are present, both in terms of spatial and channel attention. Using this approach, we have achieved a total accuracy of 77.87% across four lung sounds, which are normal, crackles, wheezes, and the samples which contain both crackles and wheezes. This is a significant improvement over the baseline models which we have seen overall, and it especially improves the performance on the underrepresented abnormal classes such as crackle, wheezes, and the samples which contain both of them. What this tells us is that smart data augmentation, when combined with attention-based deep learning, can help us make a meaningful difference, especially in healthcare settings where every correct prediction can save us a life. So, to summarize what we have done, we have introduced a novel augmentation method called as SCA, sequential concatenation augmentation, so that we can combat the data imbalance which is present throughout our data set. We have integrated a CNN attention model architecture, which takes in both account for channel and spatial attentions. And we have achieved a reliable and improved accuracy score that supports early and accurate diagnosis of respiratory diseases. Looking ahead, we believe that this could be extended to a larger and more diverse lung sound datasets which are about to be discovered in the future, and potentially even develop a real-time diagnostic tools, particularly which could be set up in a rural or resource-limited settings with a validation of a medical practitioner available at all times. In conclusion, I would say the research demonstrates the power of combining intelligent data preparation with modern neural network architectures to tackle the real-world medical challenges. Thank you so much for your time and attention. I'd be happy to take any questions if there are.
Like, have you compared with any existing system that is available?
We have compared it with the already existing papers, sir, which were already signed on by IEEE and many other conferences, and the results which we have gotten are over their baseline and what they have gotten in the previous 5 years, I'd say.
Oh,
Yeah. Thank you.
Thank you, sir. Now we'll go on to the next presenter. So the next presenter is Amit Nagpal from KR Mangalam University, India. And the paper title is The Role of Green HRM and Leadership Diversity in ESG Performance, Predictive Insights Using AI-Driven Models. Sir, if you are present in the meeting or any of the co-authors, please let us know. Okay, I don't think he's there in the meeting. So I think that sums up the entire conference. All the presenters have already presented. Now we can proceed with the closing remarks. Uh, yes, all the presentations are done. Uh, so we can proceed with the closing remarks now. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months and kindly cooperate with the team of ICTIS 2025. Lastly, I also thank our session chair, Professor Ronak Kumar.
Siddhi,
Yes.
sorry to interrupt you. I think Mr. Amit Nagpal has joined us.
Okay. Let me just announce once again. Amit sir, hello. Am I audible?
Yes, ma'am, you're audible.
Sir, will you be able to give your presentation?
Hey, today I need to give the presentation. Yes.
Okay. Then I'll stop sharing my screen. You can have your presentation.
No issues. You can continue. Okay. Matlab basically, I joined earlier. I think I was the time is 9:30. So I thought maybe I'll join early. I need to give right now, or what you can say? I can take 5 minutes.
No, Amit sir, actually, the session started at 8 p.m. Sorry, 8 a.m. It was
Okay.
according to the Thailand's time zone. But you
Okay.
can give it right now. Almost the session has been concluded, but we can have your presentation.
Okay. Just give me one minute, bus.
Yes, yes, sure. Don't worry. It's all right.
Okay, good morning everyone. I'm Amit Nagpal. I'm glad to be here to present my research on the role of green HRM and leadership ability in ESG performance predictive insight using AI-driven model. And basically, this topic is like this study brings together the environment responsibility, HR practices, leadership diversity, and AI to understand their role on ESG performance. Let's talk about the content that I will discuss one by one: the abstract, introduction, the research objective. After the sector is ESG impact sustainability, research methodology of my paper, research discussion, and the conclusion and future scope and references. Now coming to the abstract, coming to let's begin with the overview for that abstract. This abstract, the aim of the study is to focus on research and methodology, what are key finding as well as, and a research gap emphasizes on this thing. The research focus basically we need to investigate the role of leadership, diversity, and green HRM, and how they influence the ESG performance of any company. And talk about in this that we will take the methodology that will I will take the two tools, a machine random tool model that random forest and ZZB boost. Later, I will take LSTM also, but I need to check for the time series for the next 5 years also. The key finding shows that a 10% rise in leadership diversity, it increased the ESG score of a company. It means show the positive correlation. The research gap also few that it means you need to set up some industry benchmark, some sustainable development we need to improve for that. And that emphasizes it is that we need to have to go AI-based ESG trend prediction tools that can predict the ESG score. For that, we can understand how in future that we need to improve this thing. Let's talk about to continue my abstract in the beginning. For that, I have to use the data analysis approach here also. For that, I have done the stock market analysis also. I believe in the NSD, National Stock Exchange. It shows that how market perform like from international and historical ESG data set conducted in this paper. Next, sustainability impact. It involves companies adopting sustainability practices and how ESG transition are likely to experience higher financial stability and investor confidence. This thing. Risk assessment means when companies ignore the ESG practices, how happen with them the market share in like volatility is that and the risk increase the exposure of about this thing. The state integration, when talk about international level, they underscore the need for companies to integrate sustainability policies into strategic decision. It would make the energy transition programs and environmental footprint management. Let's talk about the introduction part for that. Yes, I know that I have taken two variables, green HRM and leadership diversity. And basically these two variables impact on the ESG of any company, the score performance of the company. Like talk about the green HRM. What is green HRM? Green HRM play a vital role by implementing eco-friendly HR practices like sustainability. You can use paperless HR work, you can use remote working, and you can improve your employees by the giving a training sustainable and working that they can behavior can be changed, they can adopt sustainable training and they can support in this thing also. For any kind of sustainable changes required in the organization. It talk about this thing. Then if you use this kind of thing that you can have three things in the company. One is follow rules better, improve their image, and attract long-term investor in your company. Talk about the second variable, leadership diversity. It means leaders from the like different gender, race, and talk about the experience in the background. When it comes together, it means you have to improve the decision making and you will improve your innovation, which leads to increase your sustainable outcomes. And yes, ESG performance, ESG of the like the environment social governance is often evaluated through the ESG score. Or I have taken the one introduction part in this thing, the ESG disclosure impact. It shows those companies are not going to maintaining the HR policy, sustainability things, governance. It means talking about the two companies, Adani Port and like the Bajaj Finance. They have shows a graph up and down in this thing means their volatility in the lot of in the high stock market. It shows we need to improve this thing. Okay, let's come to the research objectives. Yes, it means my first objective is that I need to analyze the leadership diversity and green transformation, how they influence or the ESG performance and financial resilience of any company. Number two, yes, I need to develop AI models. Develop AI models means ESG forecasting model using two things. The three things I can get: XGBoost, random forest, and LSTM. Enhance HM strategies. Yes, we need to enhance HM strategies means to avoid the greenwashing. It means that green hiring leadership development. Number four, strengthening governance. Yes, corporate governance should be transparent to mitigate greenwashing. Number five, integrate models means we need to use AI and blockchain models for ESG trend prediction and risk assessment. Let's talk about the sectoral impact of sustainability. First of all, let me tell you about the net zero mission. It means It means the releasing of the chemical that you increase carbon dioxide in the environment, same you need to remove for that. And for that, energy innovation for a company, they have to be use a reduction of the less emission of the carbon and footprint of the red. Is talk about the industry to industry. I have taken the top 100 company listed in NSE index stock because 100 NSE 100 as stock index rates that the how top listed 100 company show how they are using this thing or not. It talk about the sectoral part. I have taken this specifically for the like divided my area of sector wise. Specific wise, talk about the financial service sector. It means 32%, 32.7% share in the district about 100%. If talk about the financial services, they can help to the companies, those they have in the startup in the solar wind power energy. It means they can use this thing and they can help to the organization by giving some kind of discount also. They can help the startup so that they can become environment sustainably. Talk about the IT sector, 12.8%. It means these can AI driven model can be prepared to help the organization to monitor their ESG scores. Talk about Infosys company, they have their own cloud software, they are monitoring their carbon footprint as well. Talk about automobile sector, they can switch themselves to electrical vehicle and they talk about their manufacturing product. They can use recycling also. And other likewise another strategies like FMCG, they are using plastic packaging plastering, but they can avoid this less like the packaging part. They can use the palm oil like the Unilever company. They can go over that. That's example of Unilever company. And the one in healthcare, they yes talk about the healthcare also. They have some more of packaging also. They can similarly can do the less packaging and avoid this kind of things also. Talk about energy and fuel. Yes, it means yes, this energy sector they have to need to think about renewable energy, and this shows that the study that renewable energy is always you can go into less emission also. Similarly, real estate, construction, they can go for like the company Godrej, the construction building, they have used like the green cement also, like the green design. It means they can improve this thing by using this. It's sector wise. Now talk about the research methodology. My study basically examine the relationship between leadership diversity and in HRM, how they influence the ESG score of any company. For that, I need to take the data set for that. First of all, I talk about the leadership diversity. I have to take the data for the leadership diversity about the gender ratio,
Hello.
diversity ratio.
Uh, Hello, sir. Sorry for the interruption, but we are past the presentation time. Could you please get to the conclusion?
Okay. Okay, I need just have checked. Just 1 second, can you give me for 1 minute to let me tell you.
Yes.
Okay, I did correlate with correlation. I gone with a correlation, leadership ability in ESG also, how it related to each other. I found a strong relation existing. Then I take a three to, like the model, my machine learning model, random forest, XGB boost, LSTM. I found when I did this thing, I take my data like 100%, 80% trained data and total testing data. When I trained the data, I found my two variables, leadership and like the green HRM. I found about going for that two tools like the MA score, mean absolute error, RMSE root mean square error, and R score. I found my R score 0.92. It is, you talk about any relation, it related to one. It means 0.92 is, it is strongly recommend that you can increase any kind of leadership ability 10% in organization. It definitely lead to EHG score. It's possibly 0.8 to 1.2. Let what are some feature important easy prediction. Yes, it shows and out of the trend also leadership ability, sector growth differences. If any sector industry, particularly I'm talking about the finance, IT, and they use definitely the growth also because ESG also get those companies they have neglected. You talk about the three companies. I'll give you the example. PG&E Corporation, they have ignored this thing in California and they are already bankrupted this thing. Volkswagen Dieselgate, they have 30 million they fine because they were manipulating this thing because they have not at a blockchain also, so they can tamper proof this kind of thing. So misleading, they caught and a fine. Vedanta so shut down the plant because they are going more pollution in this thing. To India, they shut down the plant because non-compliance on environmental standards. Okay, let's do the conclusion part. Let me tell you about the study impacted that. Yes, sure. It conclusion leadership diversity significantly impact on EG performance and fund stability. It gives three things. Number one, you can improve your fund stability. Number two, you get government support. It means it shows gradually when you go for the US this thing, ESG score improve. When you improve green HR initiative, when you improve leadership diversity. It talk about the adoption of the enhanced corporate sustainability. And number three, AI driven ESG forecasting improve. You can use LSTM also. It shows But overall 5 years, it has been seen when taken in the past data of the history also, it means sure that gradually when you improve this kind of thing, definitely will come better. It becomes your reputation also. You get good investor also. And company must integrate ESG workplace diversity initiative. It shows company shows that to come forward to about the green HRM and ESG workforce. It means the strategy also and leadership diversity also. About the minority also, women in organization, they need to give the chance also for that. It a little bit future scope and recommendation. Yes, I found that limited also, but we need to predict this trend. We can have to decide how the future study can go for that. Yes, there is no specific tool for that, but I developed my like with SGB boost and render for us. I found my SGB tool best to any kind of thing that we develop with that, any tool, but to develop for real-time monitoring also, sustainability training also. Yes, you can improve by giving the initiative in HRM and by your employees, tell them how the paperless work is important, how this thing like the green merchant policy is important for sustainable government transparency, enhance corporate government transparency to mitigate greenwashing, industry benchmarking. Yes, there is no industry benchmark set up to peer review. If you talk about the my finance sector, how can see the IT sector they're following ESG or not? How the impact is coming to ESG score? When ESG score important, better they increase investor, the like government support, government gain. Is kind of thing that we have seen the energy sector also, when they switch themselves to renewable energy, they're getting support from the government as well. Technology integration means AI, blockchain. I also first told you ki, because it talk about a vast way. I give an example. This company, diesel scandal, they have not given it time, not use a blockchain. Now real-time things you can get it on your website. People, investor can see your ESG score. It means companies high ESG score means they are adopting this getting green nature and leadership ability. It has your reputation among this thing. Causal validation, though and you can know any method is just this thing, but cause and effect method can use. If you will improve this thing, what will happen? This kind of initiative that is required. And these are references I have taken this thing. And thank you all of you from my side. I'm Amit Nagpal, the first person member, the second my team member, Dr. Sapna Rana and Bhavesh Vyas, sir. Any question from your side? Please free to go.
Thank you, sir, for your presentation.
Any question? I'm able to take your query. Any question?
No question from my side.
Okay, since we've already given all the instructions in the closing remarks, I'll just conclude the session with the last note. I would like to extend my gratitude to Professor Ronak Kumar Patel for chairing this session. Thank you, sir, for your valuable presence. This is a token of appreciation from Team ICTIS from our side. Now, just before we end the session, I request all the participants to please turn on your cameras so that I can take a quick snapshot of today's conference. Sir, can you please stop sharing your screen? Yes, okay. Just give me a minute. I'll take a quick snapshot. We'll wait for other participants as well to turn on their cameras. Okay, I've taken the snapshot. This was a great session. Thank you, everybody.
You disabled my video. It is showing. I'm not able to open my video. It is showing you can start your video because disabled by the host.
No, actually, I've not disabled. Sir, can you please try again?
Okay, fine.
Now it is visible. I'll take the snapshot once again. Okay, done. Thank you so much, everybody.
Thank you. Bye-bye.
Thank you.